and we'll continue. Before we do, let me answer a couple questions that came in. First of all, the first question was, why do we need cross-region replication when we already have 11.9's durability? Oh, excellent question. Well, it's mostly for disaster recovery purposes. Although it's unlikely, it is possible that sometimes there may be a service that is impacting the whole region. There was an outage what, 6 months ago or so that did bring down the S3 service for an entire region. In that case, for that period of time, it was about a day, users couldn't access their S3 data. Okay, so if they had it copied to another region, they would have been able to do it. Another reason sometimes would be maybe you want to have multiple regions because you want to be close to where your customers are. And so maybe you want to have them not have a long latency when they're trying to download stuff. So you want to have the objects closer to where they are, so you could have the objects stored in more than one region. Okay. It's not about losing the data, it's more about availability and latency that you would do cross-region replication. Also, there are some security compliance requirements that say that you have to keep multiple copies of data, and sometimes they have to be hundreds of miles apart. So in order to achieve that, you would need to have it saved in more than one region. Okay, another question was, can I configure a load balancer inside the VPC for HTTP traffic so that the LB can distribute traffic with multiple instances inside a VPC? Yes, and we're going to be doing that in the later section of the presentation. So you'll see all of that later on. All right, so let's go ahead, and those are the only two questions we had so far. So let's go ahead and go back to the VPC and security group demo. Actually, let's just start it. Okay, so click on console again. All right, so they make it pretty simple to create a VPC. You basically just go under the VPC service, under networking, as soon as I can find it with my mouse. Or let me just show you this since I'm struggling. You can just type it there and it comes right up. Okay. Okay, so here's the part of the VPC console. Now notice there's already one VPC running, okay? That's what's called a default VPC. Even on a brand new account, you're going to see this VPC there. This is a VPC that's created by AWS for every account. It's so that you can do proof of concepts and quick starts. So you can just get an EC2 instance launched to get some stuff launched without having to actually have learned about VPCs and stuff like that. So they create these very simple, very basic VPCs with really very minimal security on them. So they're very flexible. So again, you can do proof of concepts and quick starts, but we don't recommend you do that for anything real. Okay, it's not secure enough. You want to be able to create your own VPC so that you can get really proper with security on it. Okay, so when you go to the VPC dashboard, there is this button right here, VPC Wizard. Now this is the easiest way to create a VPC, so really no excuse not to create your own VPC when they have a wizard for it. All right, so let's go ahead and click the VPC Wizard, and you can see there's actually 4 different options over here on creating a VPC. Now, this one here is a very simple one. It's a VPC with one single public subnet, okay? It's a /16 network and one subnet 24/24. Now, in case you don't know, that's CIDR notation, and that means how many bits of IP addresses are available. So it's going to be 32 minus that number is going to be the number of available bits. So a /24 subnet is 32 minus 24 is an 8-bit subnet, or 256 addresses. Now, once you use the VPC Wizard, you could go ahead and add more subnets to it. So this is just like you get started. If one subnet is all you need, fine. But if you want to add more subnets, you can, because you have actually a very large network. It's a /16. So that would be that one. This one here is a 2 subnet VPC, a public and a private. And it also launches an instance for you in the public subnet known as a NAT, which stands for Network Address Translation. And the purpose of this instance is so that instances in the private subnet, which don't have a route to the internet, right? They don't have a route to the internet. They can get out to the internet, but they have to go through this NAT, which will use its public IP. See, the NAT is in the public subnet. It will use its public IP to forward the request out to the internet and then bring back the data. So what use would this be? Well, like if you have an application that, for example, needs to download a patch from the internet, and your application is running in the private subnet, it would be able to use the NAT's IP to go out, get back the patch, and the NAT would forward it to the private subnet. Now, the way you set this up is you have to create a route table for your private subnet that points to go to the NAT instance in order to go out to the internet. And this wizard is going to do all of that for us. So this is going to create the public subnet, private subnet, and the NAT instance and set up the route tables so that the public subnet has a route to the internet. The private subnet does not have a route to the internet gateway, but has a route to the NAT, which will take it out to the internet. Then the third option is if you have your corporate data center and you want to connect to your VPC that way, it will set up a VPN gateway, a virtual private gateway, so that you can attach your corporate data center to the VPC over the hardware VPN, right? And the fourth one is the same as the third one, except forget the whole internet gateway. And now this would be for when you want to extend your data center onto servers on AWS instead of building them more into your data center. Like, for example, if you need another database, you could launch it on AWS and then put it in a VPC on AWS that has no internet connectivity, only has connectivity to your data center over the VPN, okay? Well, for the purpose of our demo, let's go with the second option, right? Public subnet, private subnet, and internet gateway with the NAT instance. I'm gonna click on select. And you can see it's already pre-filled some information. Now we can put whatever we want here, but it's given us a private IP address starting with 10.0.0.0/16. That /16 means there's 16 bits of addresses available, and that's 65,531. It's not the number you want because actually a couple are actually taken by AWS by default. So it's not the full amount of 16 bits, it's a couple less because they use some for overhead. Okay, so we can give our VPC a name, and this is really just for our own purposes so that we know which VPC this is. We give it a name that makes sense. You can see the public subnet already has a CIDR block defined for it. Again, we could change this to whatever we want or just leave the default. We want to pick an availability zone. Now, notice there are actually 6 choices. Okay, so this is a brand new thing, I think as of this or last week, where the North Virginia region, which I'm in right here, you can tell by this up at the management console, now has 6 availability zones, okay? They keep on growing. So you can pick one you want to put it in. I'm going to pick the first one, A, okay? We're going to leave this public subnet. We're going to call it public subnet. Let's call it number 1 because I'm going to create another one later. Then we have a private subnet. Again, it's filled in a CIDR block. Notice it's different. This one is 10.0.0. This one is 10.0.1. Okay, they cannot overlap. They cannot overlap, so that's why they have to be different. You can't have subnets with overlapping IP addresses, okay? We're gonna put this one in the same availability zone, right? And we're just gonna call this subnet private subnet 1, okay? Now down here, we have a choice of a NAT gateway or a NAT instance, either one. It will create this for us automatically. The NAT gateway is a managed service where AWS will provide the NAT capability inside of your VPC, or you could just have it launch an instance by clicking on use a NAT instance instead, and you can say what instance type you want, and if you want to be able to log into it or not. I don't, so I'm not going to bother. So this will give us our NAT instance capability. The next thing down here is very important, okay? If your applications running in your VPC are going to use S3, if you don't add an endpoint, then they're going to have to go through the internet gateway and go out on the public network to access your data in S3, okay? If you add an endpoint, then what that does is that drops a private connection into your VPC between S3 and your VPC. So now when you access S3 from applications in your VPC, it won't be using the private internet. So we definitely want to add that, okay? And the next thing, we'll leave the defaults the way they are and just create VPC. This just takes a minute, so just hold on 1 second here while it's creating. You see right now it's creating a NAT instance. That's probably what's taking, those can take up to a minute to actually generate, but it's creating the VPC, it's creating the subnets, it's creating the route tables, and it's launching the VPC. It's also creating the VPC endpoint. Okay, so it finished. That wasn't too bad, right? Okay, so I click on OK. Now we see the demo VPC right there along with the default VPC. All right, let's click on route tables so we can see the route tables that it created. Okay, we don't care about the default VPC one. We care about these two demo VPC ones. Okay, now this one, if I go under routes here, this one has a route to the internet, which is defined as 0.0.0.0 through the internet gateway, which is IGW here. So there's an internet gateway attached to the VPC. It has a route to the internet gateway. So we know that this is our public route table. This is for our public subnets. So I'm just going to name it here so I know that this one is definitely what it is, the public route table. Okay. Now it's associated with our public subnet already. Okay. If I look at the other subnet for this VPC, this one does not have a route to the internet gateway, but instead it has a route to the NAT instance. So this is our private route table. Okay, now it's not associated with any subnet yet, so the way you do it is you click on Edit and you choose the subnet. Okay, so we've got our two route tables and we've got the two subnets associated with their own route tables. Okay, while I'm here, I'm going to create a security group because we're going to need that later. Now, security groups are available either from here or from the EC2 dashboard. I'll show you from the VPC one. So you click on security groups. Here's one that already exists in my account, right? You just click on create security group. Right, and then you give it a name. I'm going to call it public web SG, and we're going to use this to launch our instance into it later. So public okay, and you have to make sure you pick the right VPC, right? I need to be the demo VPC. Okay, so I've created a security group, but I haven't added any rules. So that's on the next, so I need to go there and actually add some rules. So basically I click there and then I go to inbound rules and I click and add some rules. So I click on edit. And for this, I'm going to want HTTP traffic. So I pick HTTP port 80 from here. And for the source, I want to type in 0.0.0.0/0. That's the way that we designate the entire internet. Okay. Now, I may also probably want to log into this instance. In fact, later on, I do want to. So I'm going to need to enable SSH. Okay. So when I create an instance later, I'm going to launch it in this security group, and the security group is going to need to allow me to do that. Now, I know that I'm going to be launching a Linux instance, so I'm going to need to SSH on port 22. So I want to click Add Another Rule, and I want to click SSH port 22, right? Now this, I could be lazy and put the internet again. Now I don't want to do that because it's not really safe to allow anybody on the internet to be able to SSH to my server. And now they would have to have the private key. We'll talk about that later, the key pair. But still, it's always best practice to put your address in here. or the IP address block of your offices where your administrators work from. So it's always a good practice to put that there. So this way, unless the person's coming from that IP address range, they won't be able to make an SSH connection to your Linux instance. So I'm just going to click on Save. Okay, so I've got those inbound rules. Now, I don't have to do any outbound rules for two reasons. One, anything coming in is going to be allowed back out, but also outbound rules are already got all protocols to the internet allowed. Okay, all right, so that was it for that part of our demo. Let's go back to the slides for a little bit before we come back to it.